Okay, so this here is the entire key to solving this problem for any number.
Well, but this is all ones would only work for odd numbers.
Ah, very good observation.
So
why is that?
Because you don't have any. It's not. None of these numbers are even.
None of the numbers are even. So this, we got lucky. With 7, we found that 111,111 was divisible by 7.
Yeah.
Did you know that?
No.
No. Well, there you go. So it won't work for even numbers. For even numbers, there's going to have to be a 0.
Yeah.
Will this work for all odd numbers?
Well, no, it won't work for 5s.
Why not?
Because you have to have a 0 for 5s.
You have to have a 0 for 5s. Okay, so we don't know. Maybe there's some other odd numbers besides multiples of 5 that it won't work for. We don't know for sure, but it works for some odd numbers, and we got lucky it worked for 7. But there's a different idea here. Besides finding one with all ones, there's something else, and it's actually on the board right now.
Well, you could do ones with zeros.
Well, I'm going to look at these all one numbers. Tell me something else you noticed that we found in our list here, besides this one that was divisible by 7. Sorry.
Well, we found a sequence that is repeating.
Ah, we found a sequence that repeats.
So.
Where the remainders repeat. Is that always going to be true, that they repeat?
Well, you're doing
as I make this list, longer and longer?
Well, yeah, because you're going to do the same thing to every single one of these, and you already have what you do to 1, and you get 4, and I'll have it down here, and it'll do the same thing again.
Yeah, so for 7 it repeated. But what about if I did it instead of 7, what if I did it for 112?
Well,
would it repeat?
Well, no, because 112, you couldn't find any that was on here. Because 112 is even.
112 is even, so that means I would never find a remainder of 0. But would my list eventually start repeating? Or would it never, ever repeat?
I think at some point it would start over.
Why?
Well, it started over here. Once you hit 0, it started over.
Okay.
So, maybe it won't, because you're never going to hit 0.
Okay. We definitely aren't ever going to hit 0 for 112.
Well, what if there's some other cases where you repeat?
Yeah, what if you don't necessarily have to hit 0 to repeat?
So, well, how would you do that?
Let's try it with 4. Let's look at the remainders. These are the remainders of 7. Let's do it with 4, and let's see what happens. 4. So what's the remainder when I divide 1 by 4?
Well, it's 1 again.
1. How about 11?
Well, 3.
How about 111?
111. That would. Well, 100. I think 100 is divisible by 4, so it would be, so we have 104, 108, so it would be 3.
Okay.
3 now.
How about 1,111?
Well, 1,000 is divisible by, 1,000 is divisible by,
I think it would be 3 again.
So 1,100, yeah, it's 3 again.
It's 3 again. So 4 seems to also repeat.
But
You're gonna get 3s because if you add 1 to all of these numbers, you end in 12 every time.
So
and that's divisible by 4.
Okay, yeah, except for the first one.
Yeah.
Where do you end? See it.
So it does.
So 4 seems to repeat even though it doesn't hit 0.
Yeah. So maybe there are.
Maybe all numbers repeat.
Yeah, and
Whether
the question
or
is
not they
why?
say.
Why would it start repeating?
Well, maybe because some numbers that you hit up here, like this one is a multiple of this one, but they don't have the same remainder.
Yeah. Well, let me ask a different question.
Yeah.
Am I going to see the same remainder ever for all numbers. Like here I saw 3 and 3, here I saw 1 and 1. Is that going to happen? It won't necessarily have to be 3, it won't necessarily have to be 1, but am I going to see the same remainder somewhere on the list, or is there going to be some number where it's always a different remainder?
Well, you're going to I think you're going to see the same remainder at some point because there's a set number of remainders you can have.
Ah, how many remainders can I have?
You can have, it would be n minus, if for a number n, it would be 0 to n minus 1,
Which is how many?
which is n remainders.
There's only n possible remainders. So that means I have to have
A repeat.
a repeat remainder eventually, because there's not infinitely many different remainders.
So like, even if you had like a number like 1,000,000, you still have to repeat.
At least after 1,000,000,
You would
after a number that has 1,000,000 ones in it, I would start seeing
Yeah.
the same. I would have to. It might be earlier, like with 4, I started seeing the same remainder right away.
Yeah.
With 7, it took a while. Notice I never saw a 3 here.
So maybe it won't hold a pattern. You may see a 3 later.
You might see a 3 later.
But you're doing the same thing. You're doing the same thing. So you get 4, then 6, then 5, 2, and 0.
Yeah.
So maybe you won't see a 3.
But I eventually saw 2 1s. So I don't have to see all of the remainders, it appears. Like here, I never saw a remainder of 2. But I did see a repeat remainder,
Which was 3.
which is interesting. Here it was 3, here it was 1. And we have the idea that for any number, it's eventually going to have to repeat,
Because you're going to use up all the remainders.
because you use up all the remainders. Do you remember what this is called, where you're forcing repeats eventually?
Is this like choosing numbers?
It's called the pigeonhole principle.
Oh yeah, so it's like sticking things in holes.
Right, you're sticking pigeons in pigeonholes, and you only have, in our other case, 1,000,000 pigeonholes. And so once I have more than 1,000,000 pigeons, what has to happen?
They have to
Repeat.
They have to share holes.
Right, there has to be some that has repeated. All right, so let's talk about what that means that it's repeated.
Okay.
Alright.